3.6 parallel and perpendicular lines. So, um, let's go ahead and get right into it. Let's review what parallel and perpendicular means. I'm sure you know, but we'll go ahead and review it. If two lines are parallel, it means, let's not think of it on a grid right now, but if two lines are parallel, they go side by side. You can probably imagine what it means without actually without being able to describe it, but if you parallel, right? If we think of it in terms of a graph, so let's take this line, and remember lines go on forever and ever with these arrows. If we think of two lines on a graph, if we follow these lines forever and ever and ever and ever and ever, they will never intersect. And that's the definition of parallel. They go in, they stack without ever crossing. If we think of two lines like this, let's say one is like this, and then the other is almost like that, but it starts to cut up a little bit. Even though we don't see it in our graphing area, what's eventually going to happen with these lines? They're eventually going to cross each other. So parallel lines mean they're in line with each other. They will never cross, with one exception. If the two lines are on top of each other, they are also considered parallel, but they're also basically the same line. So it's just a special case. But yeah, perpendicular is different. They meet like this. And go ahead and write our arrows. And what's special about that is they meet at right angles, meaning they meet at an exact, at an exact square, at an exact corner. So this is considered perpendicular. If we had two lines like this, these two are parallel, and then we could have a third line that's going like this, and he would be perpendicular. So, yeah. So sometimes if we look at two lines, like imagine this one for example, if we were to just look at this part, we wouldn't be able to tell at a quick glance whether they were parallel or not. Could we tell if these two lines, let's say these two, um, let's figure out some way to measure them so that we can know for sure whether they're parallel or perpendicular. And that's what 3.6 is about. We can actually tell. Real quick, some notation. Let's call this line 1 and let's call this line 2. If we want to say line 1 is parallel to line 2, we write line 1 parallel line 2. So we just write two lines next to each other. There's an example of that at the top of page 115. And if we want to say two lines are perpendicular, let's say this is line 3 right over here, we would say line 1 is perpendicular to line 3. So we just do a little upside down T because it's a little perpendicular shape. Anyway, that's just some notation. So write down what I'm about to say in your notes. Two lines are parallel if they have the same slope. Two lines are parallel if they have the same slope. If we have two equations and they have the same slope, before we even graph it, we know that they're going to be parallel. If we have two equations and they have different slopes, we know before even graphing it, they're not going to be parallel. Okay. Yeah, let's look at 3.6b for an example. So they say, it says, we have line 1, it is 3x plus 2y equals 6, and then we have another line, 9x plus 6y equals 12. Are these two lines parallel or perpendicular? We don't know yet until we get our lines into slope-intercept form. Remember, slope-intercept form just means get y by itself. So subtract 3x, 2y equals negative 3x plus 6. Get y by itself, divide by 2, divide by 2. Y equals negative 3 over 2 x. 6 divided by 2 is 3. And then let's do the same thing over here. Get y by itself, minus 9x, minus 9x. 6y equals negative 9x plus 12. Divide by 6, divide by 6. we've got y negative 9 over 6x plus 2, but remember 9 over 6 can reduce. We got 3 over 2, so negative 3 over 2x. Are these two lines parallel? Remember, all we got to look at is the slope. Slope is negative 3 over 2. Slope is negative 3 over 2. Yes, they're parallel. Remember, the intercept does not matter because we can graph these. We have negative 3 over 2x plus 3. Plus 3 is right here. And then our negative 3 over 2 says go down 3 over 2, down 3 over 2. And then our other one was negative 3 over 2 plus 2. We start here, 3 over, down 3 over 2, down 3 over 2. So see, we have two lines side by side, and they're going to be parallel. All right. If the two slopes are different at all, not parallel. So I don't want to make this lesson any more complicated than it needs to be. You should have already written it down. If two lines have the same slope, they are parallel. If they don't, they are not. Now, this is the rule for perpendicular lines. I want you to write this down too. If one slope is the negative reciprocal of the other slope, the lines are perpendicular. Let me say this another way. If the two slopes multiplied together equal 1, we have multiply together to equal negative 1, the lines are perpendicular. I'll say it one more time. If the two slopes of the lines multiply together to get negative 1, we have perpendicular lines. Let's take a look at example 3.6e. We've got one line. We've got y equals negative 5 over 6x plus 1, and we got another one, y equals 6 over 5x minus 3. Are these two lines perpendicular? I don't know. Let's multiply one slope by the other slope. We got negative 5 over 6 times 6 over 5. Cancel, 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 cancel. Remember, these don't become zeros, they all become ones. So we just have ones across, and then negative right there means we have negative 1. These two lines are perpendicular. Let's graph them. Negative 5 over 6 plus 1. Plus 1 means that's our intercept. Negative 5 means go down 5. The 6 in the denominator means go over 6. Down 5. Over 6. Somewhere. I don't know, I lost track. And then the other one was positive 6 over 5 x minus 3. So negative 3 plus 6 over 5. And if we were to graph these, this one would go this way, and this one would go this way, and see, they meet perpendicularly. Isn't that cool? All right, let's take another approach. Let's say we have the equation, we have the equation y equals 2 over 3x plus 1. We want to find a perpendicular line. So if we want to find a perpendicular line, the slope needs to be the negative reciprocal. Remember, what does reciprocal mean? Just flip it. So instead of writing 2 over 3, we would write 3 over 2, and the negative reciprocal means that's negative 3 over 2x. And then the intercept can be whatever. We'll just say minus 5. So if we were to graph these two things, positive 1, 2 over 3, 2 over 3, 2 over 3. All right, and then another one, minus 5, negative 3 over 2, negative 3 over 2, negative 3 over 2. If we were to graph these things, whoa, that last point was way off. Anyway, yeah, so if we want to find perpendicular lines from a line we already have, negative reciprocal, and if we check 2 over 3 times negative 3 over 2, cancel, 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 we're left with negative 1. That's our test. So, in a recap of this lesson, two lines are parallel if and only if their slopes are the same. Two lines are perpendicular if and only if you multiply their slopes together and they equal negative 1.